I know how to do it. So start the recording. Let's do my screen share. Share my screen. Hopefully I don't share anything I don't want to. And, okay. Y'all see this? Should I zoom in on this view? Zoom. Maybe that's too much. Can you read that?
Mm-hmm.
Okay. So find the equation of the line that is perpendicular to 3x minus 4y equals 12 and goes to the 0.64. So I literally cooked this up this morning. I don't even know what it is yet. So I'm going to work through this with y'all, and y'all work through it. See if we come up to the same thing. Okay. Hopefully you wrote this down by now. Gosh. What's the point from there? I think I'm going to start sharing. Start working through this a little slowly. Go to my Joy Cam. Okay. What's the first thing I should do on this thing? So I'd probably pin my Joy Cam so I can see what I'm doing.
Move, oh wait. Yeah,
Okay, why?
subtract 3x.
There's like setting up a ladder like right outside my door right here, right outside the window. It's like pretty loud. I don't know if y'all can hear it, but yeah, it's pretty great. Dakota needs to come on in. You said move the 3x. That's exactly what you do. The first thing we're trying to do overall is we're trying to get the slope from this thing, right? So move the 3x over. The next thing I do is
Divide the -4.
yeah, divide by -4. Divide by -4. I'm dividing this entire side by -4. I'm dividing like two things in there by -4. Dividing each term by a -4 equals there. Y equals, I have a minus over minus. This is just positive. I have a 3/4 x. This is a minus. I don't even really care about this thing, but I'll go ahead and write it down. Let me like not do it all like maybe in one thing. Yeah, I did all this work. Why did I do it?
Get your slope.
To get my slope, because I know the slope of this thing is 3/4. And if I want the slope of the thing that's perpendicular to this, what's my perpendicular slope to something that's 3/4?
-4/3.
Yep,
4/3.
-4/3. -4/3. I believe the other thing is the point.
Yes.
I said they as in it wasn't me coming up with this problem. But anyway, third person. How do I do the next step? I have a slope. I have a point. I feel like the answer almost writes itself at this point. I can put it into where?
Slope intercept form.
Point
Close.
slope form.
Point slope. Yeah, I got a point. I got a slope. I can put it in point slope. It's horrible. It's named after the things. Okay. So y -4 equals minus, and I do x -6. And then, it depends on what they ask in the question. Technically, you probably could have stopped here, right? I didn't ask for slope intercept, but you typically want to put it in slope intercept, so I'll go ahead and finish doing that. So y equals -4, just to make sure we're on the same page. I have to use the distribution -4 there's x, and then 1. Think about this as 6/1 times 4/3. I'm dividing 6 by 3 gives me 2. Times 4 will give me 8. So I know I probably jumped that a little bit, but we've done those a few times. And then the last thing, if I want to solve for y, I gotta add that 4 over -4/3 x. So hopefully you got that. If not, hopefully you got a good ways of that and understood the process. Anybody have any questions over that? It should look similar to something we've done before. And it might look similar to things that we have in the future. Who knows? Let's do share screen. There's like one more problem I had for y'all. Let me move this out of the way a little bit. I'm not going ahead of myself. I think, yeah, we had this last time. So something like this with evaluating a function. We're doing things with like function notation. So we should be able to do both of these things. One we're plugging in a number, one we're plugging in a few symbols, right? Multiple terms. I need to know where we at. I need to watch time a little better, probably. Okay, so if I'm plugging in 3 to this thing, or if I do h of 3, I kind of told you what to do already, probably. What does h of 3 look like?
I got 25.
Yeah, I was looking for some middle steps.
Oh,
I'm doing 6 times, what, 3 plus 7, I believe. I was giving, what, 18 plus 7? And so that's plugging in a number. I think, if I'm being honest, I think most of the people are understanding like this thing. I don't think this is the thing that's tripping people up. I think the next thing is the thing that's really like giving a few people a run for the money. So h equals 7. Now we're doing like z. And so what does this look like? What's the first thing I should have written here?
You plug in z minus 1 for t, so they should read 6 parentheses z minus 1 parentheses plus 7.
Oh, yeah, I love it. You said the right word, parentheses. If I plug this thing in, I absolutely want to put parentheses around this. So this is z minus 1. I got this a little crammed in there. I have to distribute it, and I have to distribute that 6 to both of those things. If you don't put parentheses, you're probably going to miss z minus 1, and you'll get the wrong number. What is this? I didn't even do this ahead of time. We can simplify a few terms. 6z, what, plus 1?
What I got.
Yeah, that's it. And so if I wanted to say something like h of 25, right? I could say something like that. And that would be the correct notation. When I plug in 3 to my t variable, I get 25 out of that. And so this is okay. Don't go trying to divide this thing, right? Just like mental note, this is not multiplication. This is we're inputting it into the function h. So these parentheses represent, it's an input, not multiplication, right? It's very much different. The distributive property doesn't work because it's not multiplication. It's like one of the examples we had last time in the homework. We could say something like that: h of z minus 1 equals 6z plus 1. Okay. You can always tell like a mathematician by how they write their z's, right?
We always cross our Z's. And a lot of times the sevens too. I don't know why I do that.
Yep. Well, like when you're writing, you want to differentiate your z from a 2 from a, I don't know what else might look
Well,
like.
that's why I hate it when they use the variable s in a problem, because my s's and my 5s always look alike.
Okay. And so now I guess we actually have to get onto the stuff that we're doing today. So 3-6, hopefully you look at the video. It was basically, what did all we do? We did determining whether something was a function graphically. I think they made you do like some t-charts with things that weren't linear. And then they made you determine whether they were functions. And then the last thing we did was like evaluating the function at certain values. So evaluating the function at certain x values, evaluating the function at certain y values, talking about x and y intercepts, domains and ranges. And so I don't even want to spend a lot of time on these. How do you determine if something is a function graphically?
If x doesn't repeat.
Yeah, that would be like more symbolically if you have a repeating x with a different y, right? So that would be symbolically. What does that look like graphically? So I mean that's correct, but I mean there's a really easy way to determine graphically if it's the function or not.
Vertical line?
Yeah, vertical line. So a vertical line would have a repeating x with a different y values, right? If you think about like points on a vertical line, they're going to have the same x, but a different y. And so graphically, if we do a vertical line, and guess what, it hits more than one point, then what do we say?
Not a function.
Yeah, not a function. I love it. There's like all these little names popping up. When you unmute your mic, it's great. I'm seeing multiple people answering, so I'm hoping like if you're not answering, I'm hoping like you don't have a question, because right now would be the time to ask them, right? Don't stay silent is what I'm trying to say. If you have a question, I can guarantee you at least like 10 other people probably have it and they're too shy to ask it. That's usually the case. So I just want to go through these like graph by graph, and I know not all these are on your homework assignment. I think these are the correct numbers. I didn't double check them to be honest, but I believe those are correct. 337, 339, 347, that's it. Those are the ones that you actually have to write out. If you want to draw like a rough sketch of those graphs, you can draw a rough sketch. It probably won't take you very long. 337, A and B. I'm just going to read these left to right and be really lazy. So I want you, like, as a class to answer these. I don't think it should, I don't want to spend a lot of time on this because I think it's something you have to look at the graph and you can tell, you can put a vertical line on there. Is this a function or is this not a function?
Not a function.
Not a function because it hits more than one point. Function or not a function?
Function.
Yeah, it's very close right through here, but I think it keeps going up throughout the whole thing. It doesn't ever go straight up.
That looks like a cube root parent function to me. Yeah, but
So I could see if you're looking throughout here, you might like start making that sound, sucking in your teeth, right? But yeah, it's okay. It goes through, it keeps going up. It doesn't ever level straight up and down. This thing, is it a function?
Yes.
Yes, it is a square function. Oh man, I'm so stupid asking this again. Is this a function? No, circles aren't functions. Is this a function?
No.
No. And so this is like, kind of like you have, put it into negative sign there. So it's like you have the positive square root and the negative square root. Sort of like this before, right? But if you're getting two different y values for every x you put in, that's also a good indicator it's not a function.
so do you mind if they just say, when we ask for a reason, I would just say it doesn't pass the vertical line test. Is
Yeah, if we're
that-
giving them a graph and then they want to justify it or need to justify it, saying the vertical line test is fine.
And I usually abbreviate it VLT, like bacon, lettuce, and tomato, but VLT, because I don't like to write all the words out.
$340A, is this a function?
No.
No. And if we look, maybe you have to look kind of closely, but if you draw a line, it's going to hit it twice, like right in there, right? Did it hit it twice over in here as well? This one, is it a function?
Yes.
Yeah, so it looks like really close in here. It's just really steep, right? But it is still going left and right. It's not going completely up and down. This looks sort of like the cubic function. And this one, is it a function?
No.
Okay, that's good. It's going to hit it twice, right? That looks like what? Absolute value of y or something weird. I'm not sure we talk about those too much. Okay. What's the next one? 347? And 359. I really want to give you like one of these too. I feel like I was looking at those and I think it's pretty good. I think if we do these three problems and we go off into groups and do them right quick, that might be the ideal sort of thing to do. Don't want to do groups. I'm debating whether I want to do groups.
I know, but by the time you put them in, take them out, put them back in, it's like,
Yeah, I think we're just going to do them in here. Oh, I didn't read you the instructions on these guys either, huh? So graph each function. That was the first thing you should have been doing anyway, right? State its domain and range, and write the domain and range. What? Okay, that's the same thing.
you know what, about these though, like 34, 347, 351, they do know how to do those without plotting points, but then
Mm-hmm.
359, they do not.
Yeah, they're gonna have to do something a little different with 359.
Yeah.
We don't know tried and true ways to get them things yet. Do y'all hear that ladder, or is it just really loud on my end?
I hear it.
I can hear it.
Okay. I don't know why they're going on the roof, man. I hope it's like hoping ain't AC issues for someone. Like that's gonna be hot. Sure, it's hot enough for them climbing up there. I've done some roof work before, and it ain't pretty. Black shingles aren't ideal.
Yeah, and on the written part, the graded part of the homework, there is one just like almost just like 359 where you have to plot the points.
Okay, I think it's time to at least like start going over these a little bit. So 347, 1/2 x plus 1. So I want to graph this thing. What's the first point I should put on there?
0, 1.
0, 1. And then how do I score points? I go where and where?
Up 1 over 2.
Up 1 over 2. Up 1 over 2. 1 over 2. Where's my ruler? should be what our graph looks like. It shouldn't be like any sort of mystery. This should be a line. And so they want the domain and range of this thing. And so what's my domain and range on this thing?
I got the domain -4, -2, 0, 2, 4.
So if I want the domain, that's like asking how far left this thing goes.
To infinity?
It goes to infinity in the negative direction. And how far right does it go?
To infinity, positive?
To infinity. Okay. And what about the range? We go left to right, we go bottom to top. So how far down does this go?
Negative infinity.
Yep. And how far up does it go? I almost read it. Yeah, it's infinity. It's going all the way up. It keeps going up, right? Okay. So this is a line. And in general, like if we look at this thing, is there any real number that we can't take a half of and then add 1 to? Like we can multiply by a half and add 1 to any number out there, right? And so I'm going to go on a little bit of a tangent here. But there's two sorts of things. Well, if they ask, this is the way I'm going to phrase it. If they ask you the domain, really like don't think about what the domain can be. Think about what the domain can't be. Think about things that might restrict it, right? And so we've already talked about like this sort of thing. If we have a number on the bottom, we can't divide by what number? What's like the first commandment of math? Thou shalt not divide by
0.
0, right? And so if we have something that's being divided, we can't have x and being a 0 on the bottom. And so this is going to be, I think there's two main restrictions that we have in this class. There's more when we get to logs, but those are at the end. But there's two main things that they're going to try to catch you on. And this is one of them. Like we can't divide by 0. And the other thing is if we have a square root and we're talking about real numbers, this thing, and we've done, I think we do this, and we do the graph of square root. This thing can't be what?
Negative.
It can't be negative. Can it be 0? Square root of 0? Is that the thing?
Or it's rooted.
If we take a square root of 0, what do we get? Do it in your calculator. If you don't know.
That'd be 0.
That's 0. It is 0. 0 times 0 gives you 0, right? So the square root of 0 is 0. It's a weird thing, but we can take the square root of 0. We can take the square root. We can do 1 as well. 1's a stupid number. Sorry. 1 times 1 is 1. Okay. We can take square roots of 4 and 9 are good, right? We can do positive square roots. So if we have a square root, we can't take things that are negative is going to be the restriction. And I think I'm probably jumping the gun a little bit here, but you know, you're seeing it for the first time, so maybe it'll sink in by like the
And I always think that in 2020, someone must have divided by 0. I think that's why we're having this here.
Probably explains a lot.
It explains a lot.
Okay. Oh. And so that was a little bit of tangent. So back to what we're doing. This is 347. We drew our line. It was a linear line. There's nothing that's going to mess up on a linear function. We can plug in anything to a linear function. We can plug in any real number into that thing, and it's going to spit us out all the real numbers, right? That's the way this sort of thing happens. It goes from left to right, bottom to top, all the way. $351. So what's like this first set of like, what's the first point you can give me on that thing? 351. It says f of x is minus 3. Do I go down to minus 3 where?
Right there.
Right
Draw a line.
Minus 3. Draw what sort of line? Oh. They asked for this in interval notation, didn't they? That's weird. Huh. Okay. If I want the domain on this thing, what's my domain? I'm going left to right.
Positive infinity.
My range is what?
Same.
Right.
Yeah, that one's a little tricky, huh?
One's going up or down.
Yeah, it's not going up or down, but how far down?
Can you say it, Timothy?
What
It would be
possible?
Like I know there's 3 somewhere in there.
Yeah, so what possible y values can this be? We're going bottom to top. We're not jumping a long distance from the bottom to top because there's only one number.
0, 3, probably. Or -3.
Going through, right? That's the one y value that it goes through. So that is a weird one.
So if there's a single value, you write it out like that.
Yeah, that's how you would write it out in set notation. In interval notation,
There's no way to do that.
It's
Give me 2
convoluted.
values.
Or you could go from, yeah, that's it. That's all I can think of how to do it.
or minus 3 to 3. Do you write it? I don't think you write a comma on
I
that.
don't think so. -3 to -3. I
I
usually
think it's
write
just a
that
hard
later.
bracket 3. Yeah.
Yeah.
I would prefer it like this probably because it, like you see, it's a one member sort of set. It's a really weird thing to write a single member set in interval notation. We typically
Yeah. Negative infinity to -3 intersected with -3 to positive. Yeah, I mean, you can write them in weird ways, but it doesn't make sense really to do that.
Okay, so 359. 359. So this is the one you have to do a little bit of work for. So what else? Hopefully, plug in 0. What am I going to get out of this thing?
0.
0? Okay. If I plug in, I'm going to go with -1. That's probably like the next thing I would do. Or a positive one. If I plug in a -1, what am I going to get out of this thing?
Nine.
I don't know why. I'm plugging in a -1. So what does that look like? -3, -1. So what am I going to get out of that thing?
Negative.
This -1 squared is going to square to what? A +1. We're going to multiply +1 by a -3. Should get -3 overall. What about if we plug 1 into this thing? What are we getting?
-3 as well.
We get the same number because we're going to square a positive number, and it's not really going to matter. What other number? 2. Let's do 2. 2 pretty good picture for me. So if I plug in a -2, I don't think I can go much beyond that, huh? What is that?
-12.
Yep. So that's
12.
And what happens if I plug in +2?
Be -12.
Yep. Same thing as well, right? Okay. Now I need to graph this thing. -2. I'm just gonna pretend like it's up there somewhere. -1. No, sorry, wrong direction. -1. Probably down there. -3 and -1. Going through the origin, it's going through so we know this thing is a square function based off of that chart that was in your notes. You should sort of know what this thing looks like. What does it look like? What is the general shape of this thing? What sort of general? Yeah.
Like a U, like an upside down U.
Yeah, like a parabola, right? Like a U or a parabola shape. That's it. Something like that. It looks like an inverted parabola. Frowny face is also unacceptable. Answer. Okay. So we want the domain range the same. So what is my domain here? And I know it's not the best John graph, but how far left does this thing go?
Well, it's going down. Would it be considered infinity?
It's going down, but it's also going left a little bit. Not very fast, but it keeps going left. It is going out left. Yeah, so it is going off to -infinity. And so it's going off to -infinity there. How far right does this thing go?
Infinity as well.
Infinity as well. We go left to right, we go bottom to top. How far down does this thing go?
-infinity
To -infinity. And how far up does it go?
to
0.
0 with the bracket.
0 with what sort of bracket? Hard or soft?
A closed bracket.
Closed. Yeah, closed hard bracket. That's it. Because it includes the origin 0, 0, right? It includes the 0. It is a point on that graph. It includes it. We include it in our interval. Questions about this guy? How we're getting -infinity to infinity? So again, we're not like dividing by a 0. We're not doing a square root of a negative number, right? So those are the general two things that they do. But if we look at this -3x squared, is there any number out there we can't square and then multiply by 3? I'm pretty sure we can do that to every real number out there, right? Which is why we talk about everything from -infinity to infinity. We can plug anything in there. It's not going to mess up.
Would you way to like the domain in interval notation? Like, is that?
I'm sorry. Are you okay?
That wasn't me, but is there a way to write the domain in interval notation, or do we just leave it at that?
No, that is interval notation. So interval notation is we go from the least to greatest, right?
Oh, okay.
Yeah, I'm not sure. Maybe you're thinking about set builder notation. there's the inequality, right? When we're doing inequalities, we have the set builder.
Oh yeah.
Is Michael okay?
Me, I'm okay.
Okay. I thought I heard you a while ago. Okay. Yeah, this one's not easy to write in inequality, is it? Yeah. Trying to think of something. Yeah. Doing everything greater than 3. There was like we could write it as what x is greater than or equal to 3, or the other thing we could do is what from 3 to infinity, right? So those were the two sort of like formats we had for writing intervals. So if that if that answers your question, I'm not sure what your question exactly was anymore, but hopefully that like answers the two formats that we had, right?
Yeah, I was thinking of the first format that you wrote.
The inequality or set builder, right, is what I'll call this one. So this will be the inequality, which is it's part of the set builder. We just like throw in, tack on a few more stupid conventional math symbols, and we're there, right? So the inequality or set builder, and then this is the interval. So we are doing that is the interval notation. I guess the other way you could write this is also saying all the R script. It's like R with an extra little line on it, and this means real numbers. Okay. So I think we got a few more to go through. Any questions over all the stuff that I've just like went through and piled on you right here? Okay. So I believe we got 377, 379. I think we should go ahead and probably just do all these, to be honest. There's like 3 of them there. We got to write out the domain and range. And we got plenty of time. So I want you to find the domain, and I want you to find the range of these things. And I want you to write them in interval notation. I might need to go get a drink right quick. You'll ever try to drink like upside down to like cure your hiccups? You know that one? Am I just talking crazy talk now?
Oh, I've heard that before.
Yeah, if you like
Interval
completely.
is with the soft brackets and the hard brackets, right?
Yeah, that's it. We go
Okay.
left to right, we go bottom to top, and you write the number in there, and you write a comma in between them, and you write either a hard bracket or a soft bracket. Sometimes you might have to throw an infinity in there. I don't know. Something like that.
378 looks like some kind of fraction or something. Or maybe not.
Oh,
Maybe it isn't. I don't know.
yeah,
Just
you
looks
got
like it.
no. It shouldn't be a fraction, but you do might have to look up that scale there.
Do you see it, Matt? Do you see it, Michael? Why it's not a fraction?
Yeah, I'm just saying it because it's not clearly labeled. It could be, I guess.
Yeah, it's not the clearest, but I think we can work with it.
You have to really watch the scale.
I'm gonna give y'all a few minutes to get work through this. So I think about it. The main range. Oh. Okay. Are we about ready? Saw Hunter nod his head. It's like, I think Hunter's ready. Are y'all? Everyone else with me, or did y'all fall asleep at some point? This is a bad thing about going into groups. I don't know if y'all are falling asleep or not. I know a few people are responding and active though, at least. But this one, I don't know, man. I just feel like these aren't really like probably things that are like group worthy splitting wise. It's like we can kind of talk about this as a class. These aren't the most technical, what I want to say, concept wise, right? I think a lot of this stuff is just like notation and getting the notation down and knowing where to look. So doing domain range. Guys, what is my domain on this thing?
2.
2. Go ahead.
Or bracket 2, I guess.
Bracket 2. Hard bracket, it includes the 2. So it may not be super obvious it includes the 2. But we're going to assume it has a point here.
It goes to infinity.
It goes from 2 to infinity. So you're right. What about my range? How far down does this go?
Just at, doesn't really go down, just still at 2.
So, okay, I'm glad you did this. So for my domain, I look at my x-axis, right? For my
Right.
range, I quit looking at this thing.
It's 0 to infinite.
Yeah. Now I'm looking at my y-axis. How far does it go down? It goes down until the x-axis, which is my y equals 0. From 0 to infinity.
What helps me a lot of times if I have this, I always label the starting, I just label the starting point so I can see the X and the Y. And then if it's going to infinity, I put wherever side I'm on. That just helps me sometimes.
Yeah, that's a good suggestion. But I think the way I go about it is I just ignore the accents. If I'm looking at the domain, I'm looking at this thing.
Mhm.
That thing is going from 2 to infinity. If I'm looking at my range, I'm only looking at that thing.
Mhm.
That thing is going from the 0 and it's going on up to infinity. Slowly, right? This one is a lot slower going up, but it still goes off to infinity. Okay. So this one is pretty similar. How far left am I going?
-3.
Yeah, that's a -3 over there. So you gotta pay attention to your off, as we said. But there you go, that's a -3, and it's gonna go off.
Infinity.
In my range,
0.
0 to infinity, it's the same. It's very similar to the previous one. Questions? Some names popping around. Means people are muting and unmuting. Okay. What's my domain over here? Last one, 379. For last one on this page, we still got one more.
I had it at negative infinity to infinity.
Yeah. So it's going off left all the way. It's still going left. We come in, we keep going through this thing. It's going to shoot off right all the way. So maybe, I don't know, maybe this like V makes a weird point that sometimes we have to check out. But no, it's there. We have the 0.04. The range on this thing.
4 to infinity.
Yeah, so we're going down. How far does this go down? It goes down to right here. It does not go down any further. We are ignoring the x-axis. We're just looking at the y. We're starting at 4. We're going to go up. We're going to keep going up all the way. So 4 to infinity. We do soft bracket on the infinity. On the 4, I should absolutely do a hard bracket right there. We are including a point.
Matt, can you go back to, if you will, if you don't mind, go back to like 377? Because I see people mess up on these kinds all the time. And instead of having that graph go to the right, can you make it point to the left?
Oh, yeah. So yeah, let me draw something a little different, maybe. 5. So what if it looked like that?
Yeah.
Okay. And I could also like raise and lower this thing too, right? If I really wanted to be a jerk. But I'll do one thing at a time. What is my domain on this thing? That's because it's coming in from there, huh? And I bet that's where they mess up. It's my domain on this thing.
Negative infinity to 5.
So I'm coming out here. I'm coming from the left. I'm looking, how far left does this thing go? It goes all the way left, which is like saying minus infinity. So if you see an arrow going off to the left, you should probably almost always put this thing down first, right? I can't think of any scenario where you wouldn't, to be honest. So minus infinity. We're coming in. We're going right. We're going right. And did you say it or did I can't remember anymore. Yeah, you said it 5, right? And we include the 5. We don't include infinity. My range.
0 to infinity.
Yeah, same thing we had previously. 0 to infinity. If I raised or lowered it at all, this would change, right? I guess I could flip it going down. That would flip it a little different. It'd be minus infinity to the number then, something like that.
A lot of times, for whatever reason, people put the negative infinity on the right. Remember, negative infinity, you can't, it always goes on the left, never on the right.
Yeah. Please read these things left to right, bottom to top. I'm saying those words for a reason. I'm hoping they stick.
Me too.
Okay. So, and again, make note of your scale here. They're going by twos. So there's a few things they want us to find. Can I get more of this on here? A, B, C, D. I guess we'll get 4 of them at a time. Zoom out a little bit. Maybe I can get some more. Yeah. The last two are find the domain and range. So there you go. We're going to find f of 0, f of a minus 3, f of 3. So the first 3 or 4 are about evaluating a function when they give you an x or a y quantity. We got to find the intercepts. We got to find domain and range. Okay, we don't have too much more time left. I think we might already need to go over this. F of 0, what are they saying 0?
Yeah.
What variable are they giving as 0?
Y value, right?
Hmm?
X value, sorry.
Yeah, the x value is 0. And they want what they're asking. So when my x is 0, what is my y?
0.
Hmm? So when my x is 0,
5.
when my x is 0, yeah, it's 5, right? We're looking right here. We see the point 0, 5. This is another way we can write it. So when my x is 0, my y is 5. Now what about these?
2.
Yeah, that's it. Took me a minute with that scale. A little trippy. So -3 is over here. We have -1, -2 right here. This is -3 right here. So I look right here at this point. I see the point -3, 2 is a point. So -3 gives me 2, and I'm probably giving you enough to get this other one. What is the other one? +3.
2.
Same thing. It's symmetric. It's going to be the same thing over there, right? So also I'm a 0.3. Right. Are we understanding how to do these? Like our function is function notation f of x. So if they give us f of a number, that's the x we plug in to get the y quantity, right? Now, oh, why do they do this to you? Find the values for x when f of x is equal to 0.
That's on the homework, the other homework too.
Yeah.
That's why I really think it helps to label those points, just so they can see the X and the Y.
So when they say f of x is equal to 0, what are they telling you?
What number of x gets you to 0y?
That's right.
Yeah, so when the y is 0. So y is 0. Hopefully you know this, right? Y is 0 all along the x-axis there, right? What values of x does that function cross the x-axis at? This is why I don't like the question. I just realized that they just gave you one of these.
I know. I think there, I mean, there may not be one like that, but there is. Yeah. Yeah. I don't
I
know.
just put no
yeah.
solution, I guess, because you have to put something.
Solution, none. That's fine.
Or the 0 with the cross through it. Slash through it.
Yeah, you could do empty set. I guess that's also the thing. I would just say none or no x values. Find the x-intercepts.
Yeah, I see your point.
They should have given me something with some numbers in there so I could show.
Yeah. Yeah.
We'll probably go over another one. I have the book pulled
Yeah, so
up.
you gotta be careful because again, I initially put 0 for the x-intercepts, but it's x is never intercepted at 0.
Yeah, so if you said 0, that would mean the origin.
Right.
That means
I was just thinking 0 like there's none, but 0 is actually a number, so.
0 is a number. So 0 is a thing, and that's a weird thing to say. But right, 0 is a thing. 0 is a number, and so we can't put 0. This is asking actually, and I think this is where they're trying to get at, right? This is where y is 0 is the same thing as saying your x-intercept. Find the y-intercepts. And we kind of have that up there already. That's the point. Zero 5, right? That's the other thing that's up there. My domain. So this is probably the best question out of this the sets of questions. Find the domain of this thing. How far left does this go?
-3
And how far right does it go?
to 3.
Yep. And those absolutely should include those. They are points on my graph. Already talked about them being points on the graph. So my domain is -3 to 3. My range is
2 to 5.
2 to 5. So I know, like, okay. Their scaling is a little annoying on this thing. I'll give you that. But my range here, I'm going from 2 to 5 is right there on my y-axis. My x-axis is in here. Questions on that? Let me see if I can pull up a better one. Is there one? 381, I think was the one I was looking at. Let me do a screen share right quick. And this is the last thing that we'll go over. I think we're right at time, so if you have to buzz out before I'm done with this, I'll understand. But I want to answer the same things for 381. So mainly I want to find f of 0. I want to find the x for f of x is 0. X-intercepts. All right, I think I got it mostly down here. It looks something like this. And so there was 4 questions I asked you, I think. F of 0. The x for when f of x is equal to 0. And I want to know x-intercepts and y-intercepts. And I want to do this because these things all kind of correlate with each other a little bit. So if I'm doing f of 0, what is my f of 0?
With the y-intercept?
Yeah, well, but what is f of 0? This is when my x is what value? Or shoot. So I just gave you the answer there. This is when my x is 0, sorry. And so when my x is 0, my y value is Are we together? Are
Yeah.
we together? Okay. So my y value is 2, and this is coming from the point 0, 2, right?
Right, which is like the y-intercept, sort of.
Yeah. I was just trying
Or
to.
it is.
I feel like it is.
Yeah.
So the y-intercept was another question I asked. It's 0, 2, and so this is like when my x is 0 is like saying the y-intercept. This is absolutely the same thing. I was trying to like spread a little space out in between answering those 2 questions, but jumped on them. So I guess we got it.
This notation of the f plugging in the x is only applying to functions, right? Those other shapes were not functions, so this wouldn't apply to them. All of the stuff with the f0, fx and stuff wouldn't apply to like the these squared ones and stuff like that.
You could still do a similar sort of notation on those things.
Well, you can't use f of anything because that's function notation.
Yeah, you can still use function notation for relations, though, I do believe.
Not for, no, not for relations that aren't functions.
Uh,
Yeah, because that's kind of confusing because the whole thing with functions and non-functions.
That's why, that's one reason that the function notation is so nice, because if they give you f of something, you know you're talking about a function.
I think I've seen it used, but I think it's not typically. Typically, we reserve this for functions. And I'm not going to ask you anything like that crazy confusing, to be honest. So the x is for when f of x equals 0. This is like saying what? And we will call this the zeros of the function as well. That's another name we will use for this. We'll say, what are the zeros of the function? This is like what variable is equal to what?
0.
Y equals 0.
That's like my y equals 0. That's like my x-intercepts. So this, I want the x value. So this is x equals what and what?
-2 and 2.
Yeah, so this I want the number, this I want the actual point, right? And that's how those things should sort of correlate. So I think the common thing people do is when we give them this thing, they will try to go and plug a 0 into the x. This means my y equals 0, right? And I'm asking for x values. So I'm hoping the fact that when we ask for an x value, you give me x values, right? You don't spit out a y value at me when I ask you for an x. Questions about any of this? I think it's the last thing we need to go over in this homework. So finish up this homework, go watch the Roxwald 1.4 video, and hopefully after that you'll be pretty much ready for your exam.
So if it had arrows on it, then it would be going to infinity, right?
Like this thing?
Yeah.
Yeah, if it had arrows, it would be from minus infinity to infinity in the domain. But my zeros would still be the same. These answers would still be all the same. My domain and range would be different, right? Like this is still the y-intercept and these are still the x-intercepts, even if this thing still goes. It's my domain and range to be affected by that, right? Did that answer the question, hopefully? Yeah, okay. I think I'm going to stop